Hi, just a quick tutorial here to try and help you learn how to complete calculations that involve the mole, starting with molar mass. This tutorial is based on the second stoichiometry assessment. And what we're going to do is we are going to calculate the molar mass of potassium dichromate here. And we're going to do that by looking at the number of each element in the compound and totaling up the relative atomic mass of each one of the elements for this compound. So let's start off here with potassium, which is the first one. And we've got a relative atomic mass for potassium of 39.098. And this is grams per mole. I'm going to leave the units of measurement off until the end. But 39.098, and because we have two of them right here, it's going to be times 2. And 39.098 times 2 is going to work out to 78.0196. And again, this is grams per mole, but I'm going to leave that unit of measurement off until the very end. Next, I've got chromium. It has a relative atomic mass of 51.996. There are two of them again, so that's times 2, and what we'll end up there with is 103.992, and again, grams per mole. And then the last one is oxygen. Its relative atomic mass is 15.999, and there are 7 of them. And we are going to get 111.993 grams per mole. And then last, what I'm going to do is I'm just going to total this up, and I'm going to end up with 294.181 grams per mole. And that is your final answer. Now, in terms of how I would mark a question like this, I would expect that you would complete this work. You'd show me all of this. That's 1 mark.
It's 1 a.m.
And then there is 1 mark for this this final total in terms of grams per mole. So that is the first question. The next question on the assessment dealt with determining the number of moles there would be in a certain sample size. So let's move. Okay, and the second question here asks us to determine the number of moles there would be in a 25.78 gram sample of potassium dichromate. 3 marks for this question. What I've done is I've copied over the relative atomic mass here for potassium dichromate. We calculated in the last question, 294.181 grams per mole. And what I'm going to do for this question now is we are just going to do this. We're going to go N. Just change the color back to black for now. And we're going to go N is equal to M over capital M sub K2Cr2O7 in parentheses. This means the molar mass of this. So essentially what this calculation is moles is equal to mass over, and we call it molar mass. We could call it the relative atomic mass. There's a couple different words that get used or interchanged here, but it's the same thing. Relative atomic mass is this. The molar mass is this. So moles, number of moles, is equal to mass, the mass of the substance, and that mass of the substance is this, 25.78 grams. So what we're going to do is we're going to put that up here, 25.78 grams, and we're going to divide it by the relative atomic mass of potassium dichromate, which is 294.181 grams per mole. And what's going to happen here is grams are going to cancel out. And what you're going to be left with is moles. And this should work out to 0.087 moles. And that's what we should get out of that question. Let's move on to the next question. Or rather, sorry, before I move on to the next question, apologies, I should tell you about the marking scheme. So you do get a mark for this, for stating the equation. You could, conversely, you could do this if you wanted to. It's totally up to you. You do need to show or demonstrate how it is you're figuring out the answer. Then you've got to substitute in the information with the correct units of measurement. If you don't include the units of measurement throughout your calculations, you're going to lose half a mark. So you get a mark for that, and then finally you get a mark for this. There is no therefore statement for this type of question, so you don't need to worry about that. Next question. Okay, and in the next question here, this was actually question number 3. Apologies for that. It says, using the answer for number 2, determine how many moles of potassium would be present in 25.78 gram sample of potassium dichromate. 3 marks for this. And what I did again here was I copied over the amount of moles that we have from the previous question. That's their answer here in moles. That's how many moles we actually have in 25.78 grams. So what we're going to do here is, this is a type of ratio type problem in stoichiometry. So what we need is, we need to figure out number of moles K in K2CR2O7. That's what we're trying to figure out. So we're going to start with this. And I'm going to rewrite this again. I'm going to say number of moles K equals 0.087 moles K2CR2O7 times a conversion factor. Now the conversion factor is always going to be what you are going to on the top, the ratio of what you're going to on the top over what you're going from, number of moles. So it's the number of moles you're trying to convert to over the number of moles you're converting from. So we're converting from this, and up here really you have 1 mole essentially. Remember, we don't write in ones when we're doing balancing chemical equations or formulas like this. So we've got 1 mole of K2CR2O7. So we're going to have 1 mole down here. And I'm going to put this in K2CR2O7. It might seem a bit excessive, but the idea here is that this will cancel out. And up here, I'm going to have the number of moles of potassium in K2CR2O7, which is 2. Okay, we've got 2 moles of potassium for every 1 mole of this potassium dichromate. So I'm going to have 2 moles K. What happens again? That cancels out. And we're left with a conversion factor of 0.087 times 2. Okay, so this moles part here cancel out along with this as well too. I should say that's part of that. It's not obvious. So we've got 2 times 0.087 moles. And what that is going to work out to is a whopping 0.176, and I'm rounding here to this, moles. Okay. And we're done. And in terms of the marking scheme for this, again, a 3-mark question, I would expect that there's a mark for this. You've got to have this part in here. I'm figuring out the number of moles of potassium. I need to work with this. Okay, so this whole part here is 1 mark. The conversion factor, the fraction essentially, 1 mark. The answer, 1 mark. Let's move on to the last question here. All right, and in this last question here, what we're being asked now is we're being asked to determine the number of molecules that would be present in this 25.78 gram sample of K2CR2O7. Again, I copied over the number of moles from the previous, one of the previous questions. I think it was question number 2 now. We've got 0.087 moles of K2CR2O7. And what we're going to do here now is we're going to go number of, we could say particles, we could say molecules. I'm going to say number of molecules of K2CR2, getting messy here with this, CR2O7 is equal to 0.087 moles, okay, times 6.02 times 10 to the 23rd power. This is going to be molecules in this case here, or particles per 1 mole. And what's going to happen again is moles cancel out and you're left with molecules in terms of your final answer. And what this works out to in terms of a final answer is going to be 5.2, I would say 37, around there. There's more numbers after this, but to here is good. We probably could round this off to 5.24, around there, times 10 to the 22nd molecules. And there's your final answer. So in terms of marks for this one, again, you would have a mark for showing this. There's a mark here for this part, and there's a mark here for that, for a total of 3 marks. And that, ladies and gentlemen, is all of the stoichiometry stuff, or a tutorial that helps explain all the stoichiometry calculations that we've looked at. Should you have any questions or concerns, or if you need more help, please do see me in class or shoot me a quick email. Thank you so much for your time.